Okay, question 5. Here we have 2 plus kx to the power of 7, and we're being asked for the first 3 terms of that expansion in ascending powers of x. So to start with then, as ever, 7c0, 2 to the 7, kx to the 0, adding 7c1, 2 to the 6, kx to the 1, and then 7c2, 2 to the 5, kx to the 2. And there would be other terms, but we don't need them. Let's tidy that up a little bit. 7c0 is 1. 2 to the power of 7. Let's just check what that gives us. 128. And then kx to the power of 0, anything to the power of 0 is 1, so let's just leave that there. So that's ultimately going to simplify down to 128. Okay, so next term, 7c1, well that's going to be 7. 2 to the power of 6, now that's going to be 64. And kx to the power of 1 is going to be just kx. And next term, 7c2, get out your calculator for that. 7c2 is 21. 2 to the power of 5, that's going to be 32. And then kx all squared, so don't forget to square both bits. Square the k, square the x. Okay, now I've already tidied up that first term. 1 times 128 is just 128. Second term needs a bit of tidying. 7 times 64 there. 7 times 64, 448. And third term needs some tidying up as well. We've got 21 times 32 there. So 21 times 32, 672. K squared, x squared. And that is the end of part A. Okay, part B. At the top here I've rewritten the final answer of part A, which is the expansion there. Now in part B we've been told that the coefficient of x squared is 6 times the coefficient of x. I like to write that in sort of equation terms. So we've got coefficient of x squared equals 6 multiplied by coefficient of x, and we're trying to find the value of k. So what is the coefficient of x squared? Well, that is this bit here. So that is then 672k squared. And that is equal to 6 times the coefficient of x, and the coefficient of x is this bit here. Everything in front of the x. That's 448k. Now clearly this is a quadratic equation because we've got a k squared involved. So when we've got a quadratic equation, get everything onto one side with 0 on the other side. So we've got 672k squared minus 6 times 448k. So I'm just going to get my calculator, do 6 times 448. So that's 2,688. Okay, with that taken across, then there's 0 left on the right hand side. At that stage then, we've got a quadratic equation, so factorise. We don't have the number at the end, so we're just going to factorise into one bracket, pull out the common factor of k, leave in 672k minus 2,688 inside the bracket. Okay, and then pull out the two factors, so one factor is simply k, so that is equal to 0, and the other factor is 672k minus 2,688, so that could equal 0. Okay, so this needs a bit of rearranging to find k, so add your 2,688 across, and then divide through by 672. And if you have 2,688 and you divide that by 672, you get simply 4. Now, here we then have answers for k as 0 and 4. Now, in the question, it didn't specify that the k value had to be non-zero. However, if you consider what would happen if it was 0, since we have 2 plus kx to the power of 7, if k was 0, we would simply have 2 plus 0 to the power of 7, and 2 to the power of 7, you can quickly do, if you want, 128. So that's not an expansion at all. If k is 0, then 2 plus kx to the power of 7 is simply 128, which is not an expansion, it's just a value. So in that case, we'd say that k equals 0 is a trivial answer. Doesn't particularly help in the algebraic scenario of expanding. So k equals 4, therefore, is the only one that's useful, a non-trivial value. That's why in the mark scheme you'll see that k equals 4 is the only one that's really asked for. The k equals 0 value can be ignored. Okay, that's the end of question 5.